Welcome to the Laboratory 9 using AWS to collect xDot data by Sharon and Santiago. We are going to start this lab by changing our IP address on our computer. So we're gonna set it a static IP address on the same network as our conduit in order to access the web interface and configure it. In this case, we chose the address number 2. Address number 1 in the network is the conduit. So we're gonna open a new browser and access the web interface of the conduit. And we are going to use the default username and password, that is admin. Once we are done with this, we are granted with the setup wizard, with the first time setup wizard. So we're going to follow the instructions. We first change the password, when we can also change the username. Once this is done, we set the time configuration and change our time zone. Next thing to do is to set up the IP. In this case, we are going to keep the IP static to know exactly where the conduit is. We're just going to change it from .1 to .5 to check that in fact this is working. And lastly, we're going to have the default values for the HTTPS. Next thing to do is to save and restart the device. Next thing to do is to save and restart the device. This will implement the changes that we have introduced so far. This takes a while, so we are going to speed it up. Actually, we're speeding up several parts in this video to make it less lengthy. We need to open the browser again with the correct address, and now we're going to configure the LoRa1 network settings. So we're going to start by setting it as a network server. What this will do is that it will assign addresses to the xDots that are going to be the clients connected to the server. So we change the frequency subband to 7 to leave it as a public LoRa1. And on key management, we're going to change from cloud to local keys. With this, we have the name and the passphrase. Those are the key aspects on this window that we're going to use when we are configuring our xDots. Once again, we save and restart to implement the changes. And then we move forward. We access the web interface again. And now we're going to launch our Node-RED app. In this case, the conduit is the server that is going to be running the Node-RED. As in the previous labs, that it was our cell phone. In this case, it's going to be the conduit that is going to be the host for the Node-RED. A couple of details on the Node-RED. It has different options from the one we used on our cell phone on the previous labs, because it is not the most current version and we cannot update it. The conduit has not enough space and memory to update the applications, so we need to work with what we have. So there were options that we found on the previous labs that are not available on this one, as we're going to see once we start configuring it. But we mainly had issues with the keys. We could not upload them. We had to manually transfer the keys with SCP and then give the route. Once we have the Node-RED open, we're going to select the LoRa block and then the debug block. We're going to connect them both and then we're going to hit deploy. We should see it start working. Once we are done with this, we are going to import the .at firmware, and we are also going to import the xDot library to communicate with the peripherals. Once this is done, what we're going to do is compile the code, and then we are going to upload it to our xDot. After the firmware is already installed, we are going to open a serial connection to the USB UART. Notice that this is different than the debug port. We then hit the reset button on the xDot for it to start executing. And on the serial connection, we type 80. It should return OK. Once we're finished with this, we're going to configure the network parameters. So we are going to start with the name of the LoRa network, then the passphrase, and then the rest of the parameters as indicated on the previous sections. So with this done, if we go back to our Node-RED app, we see the hello message. So now we're going to start working on something a little bit more complex. What we're going to do next is download the OTA example skeleton so that we can modify the code. We first start by downloading the example, and then we download the library. We make sure we tick the box to update the sub-libraries. Once we have it, we go to the example config.h file, and we check that in fact the OTA example is the active one. So then we head to the OTA example.cpp source file, and we are going to configure the network parameters as we did on the xDot. So we're going to configure the network name, the network passphrase, the frequency subband, and the join delay. Then we are going to send the array EE542. So we modified the C code accordingly. We save, compile, and program the xDot by dropping the file on the USB interface. So now if we go back to our Node-RED window, we should see the EE542 on the debug. The next step and the final part of the practice is to integrate the code that we worked on the last laboratory for the thermistor. So we start by changing the code. Again, once the code is ready, we save, compile, and program. We go back to our Node-RED and we see that the temperature is shown in the debug column. Seeing the temperature readings on the node read means that our xDot is successfully communicating with our conduit. So the next step is that we are going to convert that conduit into a gateway for our xDot to send information to the world. In this case, what we're going to do is change the node read flow, as also we worked on the previous lab with the cell phone, and we are going to send the temperature readings directly to the AWS, and we also need to change the way the keys are implemented. So again, we transfer the keys via SCP. We download it first to a PC and then transfer them to the conduit. So we specify the route. And on parallel, we are also going to send data to the Thingsboard interface. Once again, as we did on the previous tab, we are sending data to AWS and Thingsboard on parallel. We are not sending data from AWS Thingsboard directly. So to show the results on AWS, we subscribe to our topic and we see the results. And on Thingsboard, we register the device, we did on previous practices. And if we click on last telemetry, we're seeing the values. We can also show it on a graph. And that would be it. Thanks for your time. See you on the next one.